All right, this will be a 7th grade video for page 126. This section is constant rates of change. So we're going to have constants. Constant, that's a big vocab word. This constant, if I were to ask, what does constant mean? You've probably heard the word constant many times, but if I were to give you a definition, I would say the word same. Constant means consistent. It means it doesn't change. So like if you're driving at a constant speed, you're staying at the same speed, right? So what we need to do in this section is we're going to see if the relationship between two variables is constant. So these are kind of similar to what we've been working with. Our last section was unit rates, and with unit rates, you are given two variables and their relationships. So like 2 feet per, or in 2 feet is, sorry, let me change that, 24 inches per 2 feet. And we would then find out, well, how many inches are in a foot? And that would have been 12. So 12 inches per foot. So this is a constant because no matter what, it's always 12 inches for every 1 foot. So we would have maybe feet and we'd have inches. And we could represent this relationship in a table. 1 foot, 2 feet, 3 feet, 4 feet, 5 feet. And we could show 1 foot is 12. And then we're going to constantly go up by 12 because each foot is 12 inches. So this is 24, 36, 48, 60, and it goes up by 12 every single time. It constantly, right? It does not change. It stays the same. So what we need to do is we need to look at these tables and we need to decide, is it constant? If it is constant, then it's proportional. So that's a nice big word, proportional. Proportional means the rate of change is constant. The rate of change. The ratio between feet and inches is proportional. Okay, these are proportional. It's always constant. We always multiply feet by 12, by 12, by 12, by 12, by 12. It's always times 12, times 12, times 12, times 12, times 12, no matter what. It's always because it's constant. So we need to look at this table and decide, is this constant? Callie earns money by dog sitting. Based on the table, is the relationship between the amount of money she earns and the number of days a proportional relationship? So check this out. We're going from 1. For 1 day, she makes $16. So we multiplied by 16. In 2 days, she goes for 32, or 2 days, she earns $32. Is that times 16? Well, let's check. 16 times 2. 6 times 2 is 12. 2 plus 1, that's good, times 16. Are we adding 16 every time? Well, let's see. 32 plus 16 puts us at 48, so that's good, times 16. 48 plus 16, 14, 64. So that's good. And the last one's times 5, 16 times 5, 30, 80. So that's good too. So if the question, well, if we see, and we've proven these are all times 16 times 16 times 16 times 16 times 16, they're always constant, they're always the same, then it is proportional. So based on the table, is the relationship between the amount she earns and the number of days a proportional relationship? Yes, this is proportional. There we go. Next one, the table shows the distance she drives on 1 day of her vacation. So she's going to be driving for 5 hours, and we want to know, is the relationship between the distance and the time a proportional relationship? Did she drive at a constant speed? Explain. I see on the first one we're going times 65, because 1 times 65 is 65. So let's do 65 times 2. Let's see if we get 120. You probably already can tell we aren't going to get 120, but let's check it anyway. 5 times 2 is 10. 6 times 2 is 12, plus 1 is 13. So 130. So this is times not 65. Now here's the problem. That one's not 65. So it doesn't, I don't even have to check these. I don't even have to check these because it's not the same for every single one. So this is not proportional because she did not drive at a constant speed. And I mean, it makes sense. When you're driving, you don't always, for 5 straight hours, stay at the same speed. You might run into construction. Maybe you've got to slow down for gas. Maybe, I mean, anything. Maybe you have to drive through a neighborhood. It's not going to be 65 miles an hour as the speed limit there. So she went for 65 miles an hour here. Then she went like 60 here. And then it's a little different. And then a little different. And then a little different. But 60 here again at the end. But it's not always constant. It's not always the same. So let's make sure we answer the questions. Is the relationship between the distance and time a proportional relationship? We said it is not proportional. Did she drive at a constant speed? No, she did not. Explain. So for the first hour, she went at 65 miles per hour. For the second hour, she goes, well, 2 times 60 would be 120. So 60 miles per hour. And I don't even care about the rest. I'm not even going to look at them because I've proven it in the first 2 already. So this one's done. The table shows the number of adults required for a given number of students for a field trip. Show that the relationship between the number of adults and the number of students is proportional relationship. Then write an equation for their relationship. So let's see. Students to adults. Now I can see that I'm multiplying here by 12. Okay. I can see here I'm multiplying by something. Let's do 36 divided by 3 just to check. 3 is 1. 3 is subtract 1. Bring down a 1. Bring down a 6. That's 12. So this is times 12. And let's see, 12 times 5, is that 60? 10, 60, yes, times 12. So this is proportional. There is a constant of 12 students per adult. It's constant. It's the same in all of them, right? So we have 5 adults. We know we're going to have 60 students. So then we need to write an equation. So I want to go back up to this top one, and I want to write an equation for this one. This one, if I say, I'm going to give these two some variables, okay? And I usually choose the bigger one to make my y, because I think it's easier. That's a y, I promise. There we go. So y equals our constant times x. This is how we're going to write these equations. Our constant on this one was 16. So let's see. Does 16 equal 16 times 1? So my x is now 1. Yes, it does. 16 equals 16 times 1. The next one, I'm going to do 16 times 2. Does that equal 32? Yes, it does. Yes, it does. Yes, it does. So here's an equation for this one. On this one, my students is going to be y, adults is going to be x, and y equals how many students per adult? Well, that's 12. Now, it is possible if I accidentally switch these around that this would be, so like if I said this was y and this was x, my equation would be a little bit different. it would be, let's see, what do we multiply by to go from 12 to 1? 12 times 1/12 equals 1, or 1 over 1 equals 1, because those 12s could reduce into 1s. So y would equal 1/12 x. In other words, y divided by x, or 12 x divided by 12. But if you just make the larger number here your y, then it's just the constant that you multiplied by. That's usually the trick. We do have one on our page 126 that we're going to have a fraction like this. But I'll discuss that a little more when we get to it. So I'm going to open up this to a new page. I'm going to paste this in. We only have 4 problems on this. So it shouldn't go too long. For number 1, the table shows the relationship between the age and height of a student. Use unit rates to determine if the relationship is proportional. So what they have set up for us is for us to set up a ratio, set up a fraction, set up a division problem where we do height divided by age. 48 divided by 6 equals 8. The next one, 49 divided by 7 is 7. 52 divided by 8, well, I don't know, let's do it. 52 divided by 8, I've got 8s and 5, no 8s and 52, that's going to be 6, that's 48. So that's 4, bring down to 0, 6.5. 54 divided by 9 is 6. Is this constant? No. It is not proportional. Now, if those were all the same number, then it would be proportional. But think about it. Does your age and your height, does your age determine what your height is? It doesn't. There might be students who are older or younger that are taller or shorter. They're not proportional. It's not a proportional relationship. It's not exactly the same for every age, your height. It just doesn't make sense. It doesn't work. Number 2, find the constant and then write an equation. So we need to find out, what are we multiplying by? From x to y, what are we multiplying by? From here to here, I can see that's times 5. Well, let's see. What's 4 times 5? Is that 20? Yes, it is. 6 times 5 is 30. 8 times 5 is 40. So my equation is going to be y equals blank x, where blank is that number that happens constantly. It's our constant. It's called the constant of proportionality. And we're going to use the letter k to represent that number. So this will be in the form y equals kx. We are always multiplying by 5 in this problem, so our equation is y equals 5x. The next one, 8 to 2. I can see that it's not multiplying by 4, because 8 times 4 is 32, but I am dividing by 4. 16 divided by 4, 24 divided by 4, and 32 divided by 4. Now, we still need to figure out, what are we multiplying by? If we're going to do divide by 4, so let's do 8 over 1 divided by 4 over 1. I switched these to fractions because I want to show you, if we're going to change this and we're going to find out what do we multiply by, it's going to be like we do keep, change, flip. So I got about 3 minutes in this video still. So what I'm going to do is I'm going to do the inverse of this multiplication. So I'll change it to 8 over 1. Do the inverse, change that, times 1/4. And this here is the same thing as divide by 4. Times 1/4 and divide by 4 are the same thing. So my constant is right here. We multiply every time by 1/4. Y equals 1/4 x. So for number 3, how can you represent a proportional relationship using an equation? So, well, first, we need to find this thing. Find the constant. And that's the number we always multiply x by to make y. So let's put that in words. The constant of proportionality, or the number we always multiply by x to make y. Then we're going to put it in this equation, y equals kx. In the equation, y equals kx, where k is the constant. So our equation here, y equals 1/4 x. Here's our equation, y equals 5x. We found that this was times 5. We found that this was times 1/4. And we just plugged it into that equation, just like that. So like if I used on number 2, if I said, well, 2, 4, 6, 8, well, what about 100? Well, I know that 100 times 5, my y will be 500. I would do y equals 5 times 100, and I would get y equals 500. And that's where that number just came from. So with proportional relationships, that's all you got to do. Just see if they're constant. And I'm even going to say right now, if you want to just grab a calculator, and you don't have to show me any work with this division, all right? You can just do 48 divided by 6 and write that number here. That's 8. Just type it into your calculator. That'll be 7. That'll be 6.5. That'll be 6, okay? Just type it in. Just divide. Make sure you do every single one, because this one might have been 8. This one might have been 8. This one might have been 8. But if this one's different, it's not proportional, okay? So as long as all of them are the same constant, then we're good. But if even just one of them is wrong, is a different number, is a different ratio when you divide it, then it's not proportional.